Assalamualaikum warahmatullahi wabarakatuh. My name is Umi ATIKAH binti Ahmad Shukri. My number ID is 5121921963. Today I would like to present for our subject, which is mobile communication, for assignment 2 indoor signal site survey. Okay, so firstly I will start with introduction. Okay, the introduction for this presentation is: the mobile radio channel places fundamental limitations on the performance of a wireless communication system. The wireless transmission path may be two things. Firstly, line of sight, LOS, and another one is non-line of sight, NLOS. Okay, and then the radio channels are random and time varying. Modeling radio channel have been one of the difficult parts of mobile radio design, and is done in statistical manner. When electrons move, they create EM wave that can propagate through space. By using antenna, we can transmit and receive this EM wave microwave, infrared visible light, and also another one is radio wave can be used. Okay, next point is propagation model. Propagation model is the statistical model, is usually done based on data measurements made specifically for two things, which is the intended communication system and another one is the intended spectrum. There are tools used for the two things also: predicting the average signal strength at a given distance from the transmitter. Also, another one is estimating the variability of the signal strength in close spatial proximity to a particular locations. Also, another point is I will explain is indoor propagation. Indoor propagation is dominated by the same mechanism as outdoor, which is reflection, scattering, and diffraction. Conditions are much more variable. For a door or window open or not, antenna mounting like desk, ceiling, and others. Also the level of floor. Indoor channels are classified as, like I mentioned before, LOS and NLOS. For the next thing that I will explain is indoor propagation. Indoor propagation is inside a building is influenced by a layout of the building, and another one is construction materials. Okay, the building type is a traditional office building with fixed wall, which is we call height partitions. And another one, open plan buildings with movable wall panels, soft partitions, sport arena, residential home, and factory. So for indoor propagation model is a radio propagation model that estimates the path loss inside a room or a closed area inside a building delimited by walls of any form. The indoor propagation models are four, which is ITU indoor path loss model, log distance path loss model, Ericsson multiple breakpoint model, and the last one, attenuation path loss model. Okay, the next I will explain is theory of Indo-Rf propagation and indoor modeling. Temporal fading for fixed and moving terminals. Moving of people inside building causes vision fading for the stationary receiver. Portable receiver experience in general, which is 2, relic fading for NLOS propagation path, and recent fading for LOS path. Multi-path delay spread, building with fewer metals and hard partitions typically have small RMS delay spread, which is like 30 to 60 ns, and it can support data rates excess of several megabits per second without equalization. Larger building with great amount of metals and open ISOs may have RMS delay spread as large as 300 ns, but it cannot support data rates more than a few hundred kilobits per second without equalization. For the path loss, we put some formula, and you can refer it at the last video, at the last for our video, that we explain about it a little bit. Okay, the last one that I will explain is about the partition loss. Partition losses in the same floor. Okay, building have a wide variety of partition and obstacle which form the internal and external structure. Partitions that are formed as part of the building structure are called hard partitions, and partitions that may be moved which do not span to the ceiling are called soft partitions. Researchers have formed extensive databases of losses for a great numbers of partitions, as shown in the table. The table is you can see as reference to in our last video. So I will stop here and may my friend continue our next topic. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad LUTFI bin ADZHARI. My ID is 5121912119271. I'm gonna continue with partition loss. There are 3 partition loss. First, partition loss between floor. Second, partition loss on the same floor. And third, signal penetration into building. What you can see, the partition loss between the floor determined by external dimension of material of the building, type of construction used to create the floor, external surrounding, and numbers of window. Total floor attenuation and standard deviation I will share on the slide. On partition loss, we also get signal penetration into building. As I mentioned, there are 2 effects. First, frequency. Second, height. On frequency, penetration loss decrease with increasing frequency. On height, penetration loss decrease with the height of the building up to some certain height. At lower height, the urban clutter induce greater attenuation up to some height. Attenuation decrease, but then again increase after few floors. Increase in attenuation at higher floor is due to shadowing effect of adjacent building. On methodology, the purpose of this experiment to get line of sight and non-line of sight measurement. This experiment conduct with co and co-polarization antenna, which is Yagi 2.4 GHz, directional antenna to measure N77, N79, and N77, N78, and N79, which is N77 3.5 GHz, N78 3.7 GHz, and N79 4.5 GHz band. In theory, they are calculations to minimize or maximize the performance of the network according to Maxwell formula, but in reality it is cost and time consuming. Plus, some methodology is suggested to reduce this problem. There are three different methodologies regarding the Indo-Propagation Model, which is ITU, Indo Path Loss Model, Log Distance Path Loss Model, and Ericsson Path Loss Model. From we know, the attenuation path loss model describes the signal attenuation between transmit and receive antenna as a function on propagation, distance, and other parameters. Some models include many details of terrain profile to estimate the signal attenuation, whereas others just consider carrier frequency and distance. From result and discussion, we see that the propagation of signal inside a corridor still the subject of current studies and investigation in literature, since they are considered large size the electric waveguides with transverse dimension much larger than the wavelength between being propagated inside. The propagation loss coefficient in waveguides is generally much lower than the loss coefficient in free space, and decrease with increasing frequency due to the wave orientation effects. Antennas that generate possibility more constructive multipaths with even various objects inside the laboratory or corridor. They were between height of the antennas. The analysis of loss coefficient is widely approached in a large scale modeling at some various frequency, either to validate value which is already established, or to propose value for new environment or frequency. The value of PLE depends on specific propagation environment. It is considered the effect of propagation channel, and generally assume that for a given distance between Tx, which is transmission, and Rx, which is receiver, the loss is the same. For frequency 3.5 GHz, we get FSPL is 43.32, PLE we get 2.16, derivation in dB 1.87, and XPD in dB 18.3. For 3.7 GHz, FSPL is 43.8, PLE we get 2.24, standard deviation we get 1.94, XPD in dB we get 19.6. For 4.5 GHz, FSPL we get 45.5, PLE we get 2.1, standard deviation we get 2.4, 2.0, and XPD in dB we get 21.3. The loss of propagation in corridor and laboratory followed the behavior of waveguides. The value of loss inside the corridor are much smaller because corridor is more confined environment with concrete wall and iron grid. It also has fire extinguish and other object at the same height. For conclusion, in summary, student able to understand the concept and characteristic of the super high frequency SHF at the range of 3.3 to 5 GHz, which is N77, N78, and N79. From this experiment, students also gain a lot of information and knowledge, especially for discussion about result that students obtain during their site survey. The different result obtained from experiment with specific model made by student to understand the indoor propagation. The model used could be student guidance to predict the signal strength for indoor environment. Lastly, lot of things should be considered for the result of signal propagation, especially at open area and closed area. That's all for me. Thank you.